All right. So what you need to understand before we talk about the formulas and so forth are the Newton's laws of motion, which is the ones that affects us in these calculations. So I'm going to send this PDF on WhatsApp so that you can just jot down the notes so that it does not take us time. So if you take note, the first part, we've got the Newton's first law of motion, which is directly linking to the body that is being kept at a certain point or moving with a certain velocity, that it is not going to change its velocity or its state unless there is something that is acting upon, which is referred to as external force. So you're saying here a body will keep its position at rest or in uniform motion, meaning to say there's a uniform movement that is taking place, or there is no movement at all. So it can only keep this in a straight line unless an external force or forces change its state, meaning to say the application of external forces now causes that body to change its state, whether to move or to increase the speed depending with what you are given. That is what you have in this place. Like we've got a body in this case with a certain mass. So when there is no force that is being applied, when this body is stationary, it is going to remain like this. But once a force is applied now, this body is going to change its state. That is what we are given. Now there is a movement that is happening. Or we can have a body that is already moving. But now there's another force that is being applied. So meaning to say we are going to see a change because there's a force applied, there's a force that was already there on the movement. So meaning to say we shall have an increase depending with how the force is applied. The force can be applied opposing the direction, or it can be applied in the same direction with where the body is moving. So when it is in the same direction, we shall have an increase in terms of what? In terms of the speed. But when being opposed, we shall have what? We shall have a decrease in terms of what? In terms of speed. So this part, we shall talk about it in formulas. But for now, I just want us to have these laws. So the same law that we are talking about can also be referred to as what? As the law of what? Inertia, where we are saying inertia simply means is the property of a body to keep its state of rest or motion, to keep the same position that you are at. That is the state of what? Inertia. And we've got the second law, which is the application that it talks about momentum now, the change in momentum and so forth. So you're saying the change of momentum per time unit of a body is directly proportional to the force exerted on the body and takes place in the same direction as the working line of the force. So whenever we are talking about momentum, it's simply a product of the mass and velocity. So here I just listed some of the things that we need to know about this second law. It leads us to the momentum formula, that it is the product of mass and what? Velocity. The mass measured in kgs, our velocity in meters per second. So meaning to say our units is going to be kg by meters per second. Then we can have a change in momentum. We shall talk about these formulas later on, about the change in momentum and even this momentum as a subheading. But what we need to know about this law is that the force is equivalent to the mass times the acceleration. This is the major part that we need to know about this part, that force is the product of mass and acceleration. So the mass in kgs, our acceleration meters per square second. So the units that we're supposed to use is this one, but as we are going to use the equivalent one, which is what? The newtons. So meaning to say whenever we are talking about force, we are supposed to have our units in what? Our units in newtons, or just simply N. And so this one, we are just referring to a normal force when it is on a horizontal. Whenever we're now talking about a vertical, our acceleration is no longer the normal acceleration. We are now talking about the gravitational acceleration. So we shall see the differences that we have between a movement that is happening on a horizontal or on a vertical. So that is what we have on this part. And always we know that for every action, there's an equal and opposite reaction on another body, which is the Newton's third law. All right. So what I want you to understand is that we talked about the force being the product of mass and acceleration, but this is not actually complete. All right. Let us consider a condition that we have got a body that is let us have something like this. So this one I'm going to specify it differently. Let us put this one as a horizontal movement. We want to consider the horizontal movement in this case. So on our horizontal movement, what we are supposed to understand is that truly that the force is the product of mass and acceleration. But let us take a consideration that we have got this body here, which is on a horizontal plane. And okay, this is our body here, which is on a horizontal plane. There can be a force which is actually applied, the force that we have, which is our applied force in this case. So here we've got our F, which is the applied force. But there can be a resistance, which is the force that is opposing the movement of the body. The body is going this direction, and here it is being opposed. So this force is opposing the movement of what? Of the body. So you can refer to this one as the frictional force, which is opposing, or the resistive force, the one that is resisting the movement of the body that you are given. All right, given this condition now, there are going to be three different conditions that you can consider from this. Which is, because we are saying our force is supposed to be mass times acceleration, but now it is going to follow the rules now to say, okay, if we have got a condition like, let us say our force, which is our applied force in this case, is equal to the frictional force. It's like you are going this way, and there's a force that is equal to that is going to that way. So it means you are going to remain at a certain position. You are going to remain there, or we are going to move with a constant velocity on that manner, because these two are equal. So we are simply saying here, that's a condition where our F minus the frictional force is going to give us a 0, because these two, they are equal. It's like 2 and 2. So if you subtract these two, you must get what? A 0. So in simple terms, we are saying there is no movement in this case. There is no movement. So yes, we are referring to a condition of no movement, or we are referring to a condition whereby we are maintaining a constant velocity. But if this object that we are having, the same object now, this one F, which is our applied force now, it's now bigger than the frictional force, the one that is opposing. Remember, this is the one that is opposing the frictional force. So if this applied force is bigger than the frictional force, what does it mean? It means now there's a movement in this case. And this movement, where are we actually going? We are actually following this direction. It's like it's just like a weight thing to say. You can't say you are pulling something that is or you are having a pull from a bigger force. Then we expect the bigger force to follow the smaller force. It's not like that. We are going to see that if this is the bigger force, maybe it's 500 Newton, and it's being opposed by a 20 Newton, this opposite is not going to affect as much. we are going to still maintain the movement going the same direction, but only that we are no longer maintaining the same speed that was there. There's just going to be a drag that is happening, but going the same direction, but on a condition that this resistive force is now bigger than the normal force. We are now having this one as maybe 1000 Newton. It means the car or the object is no longer going this direction. It is now taken by the resistive force because it's bigger than what? The normal force.
Yeah.
Are you seeing the idea of this information? So that is what you're going to have in this case. So that is what I'm trying to say, that here there's going to be a movement, but the movement now you are following the direction of what? Of the applied force in this case. And whenever you are involving the frictional force, because you are saying there is a frictional force that is there, but only that our applied force or the force that we have in this case is greater than the frictional force. Therefore, we shall conclude that the normal force now minus the frictional force is going to give us MA. Remember, before, MA was representing what? I don't want us to have a confusion here. MA was representing what before? Was representing the normal force, which is our applied force. But now MA is no longer equal to this F. We are going to subtract now the frictional force from that F that we are given, which is our applied force or the normal force. We are going to subtract what? The frictional force, so that we remain with what? We remain with MA, which is mass times what? Acceleration. So meaning to say that the frictional force, once it is given, we are going to take that. But if you are given a condition that you are not given the frictional force, or the frictional force is 0, meaning to say it's not given, it means we are going back to say F is equal to what? F is equal to MA. But once there's a frictional force, it's no longer this same formula that you understand. You are going to make adjustments on that formula now. That is the difference between this one. And also, like I was mentioning there, to say we can have a condition like if this frictional force, because it's not like the normal force is always bigger. The normal force here can be less than the frictional force. If it is a condition that the applied force, this one, like I was explaining, that it's now smaller, that we are now having a bigger frictional force, the object is no longer going to maintain this direction. It is going to change now to follow where the frictional force is going, because it's now bigger than. So we are simply saying there is a movement in this case. Yes, there is a movement that is happening, but the movement that we are taking place now, it's now in the opposite direction. So this one now in the opposite direction. So meaning to say your object now, instead of going this direction, it is going to follow now where there is a bigger force, and our bigger force is at the what? At the frictional force, because we are saying our applied force is less than the frictional force. So it simply means frictional force is bigger than what? Is bigger than applied force in another way. I don't know if we are together on this part.
Yeah, we are together.
All right. So with these few terms, or with these few formulas that we have, I want us to just see some few questions that we have on the horizontal movement, because here we're talking about a horizontal movement. So this part is the one that I was explaining, that our horizontal movement, if an object accelerates on a horizontal plane, the accelerating force or unbalanced force is causing the what? The acceleration, which is the one that we have here, this explanation. So you shall just also conclude with this part here. All right, so I think this one can lead us to the questions. Let us check one or two questions here. All right, the first question that we have on our horizontal movement, we are given that calculate the force required to give a body with a mass of 8 kg and acceleration of 3 meters per square second. All right. What is it that we are given? We are given to calculate the force. All right, force, so we do not know the force. But force, we have the mass of the body, which is the mass, it's what? It's 8 kilograms. having an acceleration of what? Of 3 meters per square second. So where are we going to have the force? So I think this one is a direct one, and where we are just talking about force being the product of what? Mass and acceleration. We do not have any frictional force, anything that is opposing this body. So it's just direct, the mass that is there versus what? The acceleration. So meaning to say our force is going to be 8 by 3. Mass times acceleration. So meaning to say we shall have 8 by 3, which is going to be what? 24. Is that so? In what? In newtons. So like I said, the mass, yes, it's measured in kgs. Acceleration in meters per square second, which is fine, but the units for force, weight, is what? Newtons. That is the equivalent of this whole part here. I don't know if we are together here.
So meaning to say we have to change like 8 kg by 9.8, ne?
We have to
change kg, to change 8 kg to be in a newton.
On this one, the moment you multiply, I'm saying these units here, the kg by meters per square second, it's actually an equivalent of what? Of a newton. This is the definition of a newton. So we are not changing anything. The moment you multiply, and it's kg by meters per square second, that is the newton. So instead of writing this on our answer here, we simply write as what? As newton.
Yeah. And then
are we together on this one?
Yeah.
All right. Now I want us to check this question. This is very, very important. Let me try to adjust this way. All right. There we have information that a mass of a 20 kg is accelerated on a horizontal plane. We are still on a horizontal plane. So it is accelerated, meaning to say there's a change in speed. All right. If a force of 8 Newton acts on it, so we have got the force that is acting on this body. All right, let us just have our body aside here so that we do not confuse. All right, I don't know if you are still seeing the body clearly. I just want to have it aside here. All right, so this is our body here, which is on a horizontal plane. So we are given that this body that we have, it has, what is it that we are given? Its mass is what? 20 kgs. We are given the mass of this body being 20 kgs. So we can just write here 20 kgs inside. All right. What else do we have? We are now given that there is a force that is applied here. If a force of 8 Newton acts on the body, this is the force acting on the body. So meaning to say we are given the force that is our F in this case, our applied force, the force that is acting on our body, this one. That is the one that we are given of what? Of 8 Newton. All right, what else do we have? Then we are given that the frictional force against motion is what? 7 Newton.
7.
There is a friction that is happening against this movement that we are having of 7 Newton, meaning to say on our diagram here, we are going to have 7 Newton. Can we say this is a frictional when we are putting like this? Is it opposing this one?
No, it's not opposing.
It's going in the same direction. So the friction has to be on the other side like this. It is opposing now. So we've got a frictional force of what? Of 7 Newton in this case. This is what we have on our diagram. All right. Now let us take our consideration. Our question is, calculate the unbalanced force, which is the accelerating force. So I talked about this on those notes. That is the accelerating force is referred to also as what? The unbalanced force. So we need to calculate the accelerating force. All right. In actual sense, what was supposed to happen in order for us to have the accelerating force? Okay, let us have this space here. In actual sense, it was supposed to be like this. To have the accelerating force, we're supposed to say force is equal to mass times acceleration. That is what was supposed to happen. Like what we had in the first question. But now we can't use this direct. Why? Because there is a force here that is opposing. There's a force that is opposing there. So instead of us having this accelerating force equal to ma, because the ma is the accelerating force, there is mass times acceleration, that is accelerating force. There is what? Mass times acceleration there. So this one, we said it is going to be equivalent to what? Once there is a frictional force, we are going to subtract the applied force minus what? Minus the frictional force. So meaning to say, the moment we are saying the applied force minus the frictional force is equal to ma like this, we are having the same ma that we're supposed to have equal to F, but because there is a force that is opposing, we are supposed to subtract that opposing force. So this is the formula that we are going to use to calculate our accelerating force, which is ma. So you can write accelerating force, or you can just write ma is equal to F, which is our applied force of 8 Newton, minus the frictional force, which is what? Which is 7 Newton. So if we subtract this, we are going to obtain what? We are going to obtain 1 Newton. Are we together on this part?
Yeah, we are together.
All right, so let us check the other part of the question. Now on this side, the question is to calculate the acceleration. After calculating the accelerating force, calculate the acceleration. So it's now easier because we know that the accelerating force is the one that carries acceleration. So we simply need this part here. So here we already have this part where we have given what? Our accelerating force, which is ma, and we said ma is equal to what?
Ma is equal to
1 Newton. We have the answer already. And the mass, we have the mass of the body, which is what? Which is 20. So we can substitute our mass, which is 20, times what? Acceleration, which is equal to 1. So we can divide by 20 both sides to obtain what? To obtain our acceleration in this case. So therefore, our acceleration is going to be what? 1 divided by 20 is going to be something like what? 0.05, something like that, meters per square second, or 0.05 meters per square second, like this. I don't know if you are together then.
Yeah.
So it's a matter of understanding what you are given. If we are not given the frictional force, if the frictional force was not there, it means our applied force or the accelerating force was going to be simply mass times what? Acceleration. But because now there is a frictional force, it's no longer going to be mass times acceleration. We have to subtract the frictional force in order to obtain what? Our accelerating force. All right, let us check this one. I think I have a question that do not have the friction. All right, let's check this one. Maybe, okay, let's just see this one and move on to another one. There we are given that a body is accelerated at 2 meters per square second. All right. So what are we given there? Let us just take our information. So what do we have in this case? Our body is accelerated at, meaning to say we are given the acceleration at 2 meters per square second on a horizontal plane. Calculate the mass of the body if the applied force is, so we are given the applied force, 65 Newton, and the frictional force, we are given the frictional force of 56 Newton. All right, so this one is just similar to the previous question, only that here we are asked to calculate the mass, but the last one asked us to calculate the acceleration. But where you get acceleration, you can also get your mass, isn't it?
Yeah.
Because these two, they go hand in hand, mass and acceleration. So what we are supposed to do in this case is to ask ourselves, what is the accelerating force, even though we are not asked about it, because the accelerating force is the one that consists of the mass and what? The acceleration. in actual sense, our accelerating force was supposed to be MA. But is it going to remain as MA? Why?
Yeah,
Because
it's going
it's going to remain as that. Now
because if you subtract,
my question is, if you are we going to use this as the same formula to say this is our accelerating force? That is my question. What are you saying?
Because I was thinking, like, if you subtract that applied force and the opposition force, then you can get like a force, then you multiply acceleration and so that you can get M.
So meaning to say our formula is going to change because of what? It is going to be affected by this. So we are going to have force minus the frictional force is equal to MA. So that is what we're going to, whereby our force, that is the applied force, it's 65 minus the frictional force. Our frictional force is what? 56, which is equal to MA. We are asked to calculate the mass. So we are going to substitute the acceleration because we have the acceleration. So this one is going to be M times our acceleration, which is what? Which is 2. So we can subtract the 2, then we divide by 2 because there is just a normal equation now. All right, so if we are to subtract this one here, let me see if we can just have the calculator at once. So this is going to give us what? 65, that's 65 minus 56, which is going to be 9. Yeah. So 9 is equal to 2M. So you can divide by 2 by 2. That's our M, 4,5. Is that so?
Yeah, it's 4,5.
And our mass is measured in what? Our mass is measured in kgs.
kgs, yeah.
All right, so that is how we can have this one. So the most important part was that we were given the frictional force, so we have to subtract it. But if we're just given this applied force, our mass, we're going to use this formula because we just have this applied force. F is equal to MA. We use this one as it is. All right, so let's check another part, another one. All right, yeah, this is the one that I wanted without frictional force. Now this question, they are saying a motor car moves on a horizontal plane, meaning to see, we say we are still on the horizontal plane. And it at a velocity of, the moment they say at a velocity, we are now talking about the linear motion part that we talked about, to say this is our starting velocity. So we are given the initial velocity in this case, which is our U, which is 20 meters per 20 meters per second. Then they are saying the brakes are applied and the motor car comes to rest. The moment we are saying the object is at rest, what does it mean from our linear motion? We say there our final velocity is at what? It's now at 0 meters. It's now at rest. 80 meters further, meaning to say this part, the application of the brakes, when the brakes were being applied, it took the car 80 meters, the distance that was traveled for it to come to rest. It was what? 80 meters. So we have got the displacement or the distance that is of what? 80 meters. All right. Then from this information, again, we are given that the frictional resistance is 200 Newton. So we've got the frictional resistance in this case, which is what? 200 Newton. And the mass of the car is, we've got the mass of the car, which is 900 kilograms. Calculate the deceleration. All right, so the first question is to calculate the deceleration. With this information, how can we calculate the deceleration in this case?
Okay.
The moment we are talking about deceleration, it means we can go back to our linear motion laws, the formulas that we, because here we've got U, we've got
U.
V, and we've got S. So this
Yes.
part here can give us the deceleration. We know that deceleration simply means it's acceleration that has got what? That has got a negative. That's a deceleration. It's just a negative what? Negative acceleration. So meaning to say we are supposed to calculate the acceleration from these value that we are given. So we have to go back to our formulas. Remember, V is equal to U plus AT. We've got a V squared is equal to U squared plus 2AS, S, which is equal to UT plus half AT squared. Then the S, which is equal to U plus V over 2 times T. So that is where we have to go back now and choose a formula which is appropriate from this one to calculate A. From these, which one can we choose? Which one is the best formula there?
We can use the V squared is equal to initial squared plus 2AS.
So we can play around with this one, which is fine. So there we are going to have V squared is equal to U squared plus 2AS. We need to calculate the acceleration in this case. So you can substitute your values, or you can make A the subject, or you can just substitute V, which is 0 here. So 0 squared is equal to U, which is 20 squared plus 2AS. So we are going to have 2 times A times our S, which is what? Which is 80 meters. So that means we can be able to calculate the value of A in this case. All right, so let us see what we are going to have from this. If we transpose this to the other hand, 20 squared is what? 420 squared. So you can simply transpose this to the other hand so that it becomes a negative. So we are saying 20 squared, that's 400. But if we are to write it on this side, it's going to be minus 400 is equal to 2 times 180. It's going to be what? 160. So we can divide by 160 by 160 both sides. So meaning to say 400 actually as a negative. So we've got negative 400 divided by 160, which is negative 2.5. So we are going to obtain negative 2.5 meters per square second. So the negative that we are seeing here is indicating what? Is indicating a deceleration. This negative part that we are seeing is indicating what? A deceleration. So meaning to say you can just write your final answer as deceleration is what? 2.5 meters per square second. Yes, as we are calculating as acceleration, that's why we see a negative answer, but the exact answer for what we are calculating, which is the deceleration, is what? Just 2.5. So you can simply say there's a deceleration of 2.5 meters per square second.
Yeah.
Are we together there? Then the question that follows this one is now asking us to calculate the braking force. The braking force. Where are we going to have the braking force? What can we do now to calculate the braking force? Which idea can we consider in this case to have the braking force?
Well, not like now back to our normal questions, because we've got accelerations, we've got mass. Yeah.
So what are we going to do?
So like what we are going to do, we can just say like force subtract by initial force is equals to M times A.
So we are going to have F minus the frictional, because there is a frictional force, is equal to MA. So instead of us multiplying mass times acceleration direct and say this is our answer, the one that we are referring as the braking force is this one, which is the F, like the applied force. So now we have to make this F the subject now to say where are we going? The F this one. So let us put this so that we do not confuse this one. We are saying the F that we're supposed to have in the initial place was supposed to be MA, which is the product of these two. All right, let us find it aside here. If we multiply mass times acceleration, because we've got the mass here of 900 times the acceleration, but here we are going to take it as what? As 2,5. Remember, the negative is showing us that it's a what? There's a deceleration there. So if we are to multiply this part, what are we going to have at the end? If we are to multiply 900 by 2,5, let's see, 900 by 2,5. We are going to obtain something like 2,250 Newton. But now, because this MA is no longer directly equal to this because of what? Because of the frictional force. Therefore, it means this F here is going to be 2,000. I mean, the one that we want, which is the MA, is going to the F that we got from the initial mass times acceleration, which is 2,250. But subtracting now the what? The frictional force. That is where we are going to end as our MA now, which is our braking force. It's now affected by a frictional force. So at the end, this one is going to give us what? 2,000 and what? 2,050, if I'm not mistaken here, Newton. So that is going to be our braking force. We can just have this as the braking force is equivalent to. So I don't know if we are together on this part. So it's actually on that part of frictional force. Once it is given, you have to consider it in your calculations. That part of the frictional force is very, very important, because if it is not given, then we are not going to work with that part. So I want us to check another question. So if you are to check now on this part, it's just a similar question like the previous part. We shall only note that on this one, we are given, okay, let's take our information, a truck with a mass of 8,000 kilograms. So we've got a mass of 8,000 kilograms given, moves in a straight line at 15 meters per second on the horizontal plane. So meaning to say we have got the initial velocity of 15 meters per second. Now it is brought to rest. We are back to the same information. Meaning to say our final velocity is what? 0 meters per second. During a period of 6 seconds, we are given the time frame of 6 seconds. This time, we are not given the distance as what happened previously. To say when the brakes were being applied, now 80 meters and so forth. Here we are given the time that was taken. The question is to calculate the deceleration. That is the first part. So whether we say whether we are given time or we are given the distance, the deceleration is simply representing or indicating a negative what? A negative acceleration. So what you just need is to ask yourself, where are you going to calculate acceleration from this information that you have? Which information that can give you acceleration? This information here is enough for us to have the acceleration. Because remember, we said V is equal to U plus 80. So meaning to say this is the best formula that we can have, because we have our V being the final velocity 0, U being the initial velocity, plus AT, which is we want to calculate A, we are given T. So this is going to be 6 times A. So in order for us to calculate A, we can transpose the A this side, or you can transpose the 15. I don't know which one can you transpose, but if we are to take 15 this side, it would be negative 15 is equal to 6A. Divide by 6 by 6. So meaning to say, we are going to have an acceleration of what? Negative 15 divided by what? Negative 15 divided by 6. Which is going to be something like what? We divide these two. negative 15 divided by 6 is going to be what? Negative 2.5 meters per square second. So meaning to say our deceleration there is simply 2.5. The negative part is just showing us that to say that is what was happening in that case. Then now they need the braking force. Where are we going to obtain the braking force from? What is going to be the formula for the braking force this time?
Because as we've got a mass and we've got acceleration, so we can just say F is equals to M times A acceleration.
So that is what we have this time. We do not have anything that was opposing, which is the frictional force. So our braking force is simply going to be mass times the deceleration, because that acceleration that we are talking about, it's a negative. That's braking. So meaning to say we are going to have, or you can even write this as F braking. Does not matter whether you want to write it like that, which is our mass of what? 8,000.
8,000.
Times our acceleration of 2.5, which is that negative that we had. So meaning to say, if we multiply these two, we are going to obtain our braking force in this case. That is, let's see what we're gonna have here. 8,000 by 2.5. So that will be 20,000 in this case. So we've got 20,000 Newton, of which you can write that 20,000 Newton as what?
This is 20 Newton.
1,000 simply means what? A kilo, and so this can be 20 kilonewton, or you can just leave it like that. So I don't know if we are together on this part.
Yeah.
So these are the typical questions that you are going to have as long you are considering a movement that is happening. As long you're talking about a movement that is happening on a what? On the horizontal plane. We shall have a movement that shall happen, which is now opposing what we are representing as a horizontal. So this part, I think we shall just start it on a fresh page. But for just the basics of what we shall actually be referring to is that instead of us having this body in horizontal, we can have a body that is in this manner. And as this body is suspending, it is having a weight now. It is affected because it's being suspended. So there's now in the gravitational accelerating, which is the one that is opposing for us to go up to be wanting to go down. So meaning to say we are going to have either the force that is going up, the force that is going up at the end, or we shall have the equivalent of the force that is going down, which is taken from this one. We are saying we've got our force here, which is mass times the gravitational acceleration. Whether there's the part that is going up or down, it is due to acceleration. So here we can have due to acceleration, mass times acceleration, there's a force. Due to acceleration here, there's mass times acceleration. It just acts because there is an acceleration that is there instead of the gravitational one. There is an external force that we are supposed to have at the end. So there we are going to see that it's either we are going to have the equivalent going up or the equivalent going down. So our equivalent force going up, we can simply have this as F up. It is going up. It is going to be the product of mg plus ma shall be added together. Then for F down, we are going to have mg minus ma.
Oh, yeah. The difference is if it's going up, we add. If it's going down, we subtract.
We subtract the ma, this one, applied force, which is from the accelerating force. So up, we are going to add down, we are going to subtract. I don't know if we are together on this part. All right. So what you need is to work from these ones. So what I'm going to do is to send both notes with the other part, because we can have it as a string that is attached, like we are having a string attached to it like this. So now we are going to have either this one going up or this one going down. So still we are going to have the acceleration, but due to the gravity part, here we shall have mass times gravitational acceleration, mass of B times gravitational acceleration. So let's say this is our A and this is our B. This one, it has a certain mass. This one, it has a certain mass. They are now different masses. So it can be on a condition like that. So we shall see that even if we are to take this into consideration, now we can work with the idea of forces to say the sum of the upward forces is supposed to be equal to the sum of the downward forces. The same that we have here, F up. And we said F up is equal to what? Mg plus Ma. So when we are saying Mg plus Ma, plus Ma in this case, which M are we talking about that is going up? The one that is going up is for the object A. So this is mass for object A. This is mass for object A. This is the one that is going up. The one that is going down, it's our object B, the one that is fixed. So meaning to say on object B, it is going to carry what? The F down concept, to say it is going to be equal to Mg minus Ma. But this mass that we are talking about is for B. This mass that we are talking about is for B. It is the one that is going down. Object A is the one that is going up. So object A follows this. Object B follows this concept. I don't know if we are together on this part. Yes, hello. So what I want you to do is to take this part and into consideration. Then, like I said, I'm going to send the rest of the notes in the to your WhatsApp, so that at least you can check these questions. I mean the notes on how they are given. Then the rest of this, will see them as questions. I think that is going to be the best. Okay. So on this part, before we talk about the questions that we have, I just want to have a clarity from that last part that we talked about. We talked about if we are given just a normal object that is hanging from a certain point, to say that it is going to be affected with a certain weight due to what? Due to gravity.
Gravity, yeah.
So meaning to say we shall consider the weight of the object in this case, but the weight, we are just talking of the force, the force that is happening there. So we can have an acceleration of the body. Yes, there is a gravitational acceleration which affects the weight, which is our normal gravitational acceleration. But this object can also be affected by a normal acceleration, which is not gravitational acceleration. We are representing to the normal acceleration, which might cause this body to go up or to go down, depending with the direction where this acceleration, where this force which is causing the acceleration is affecting at. That is where we end up talking about F up, which is the force that is going up due to the acceleration. If we are given that it's accelerating up, meaning to say we are supposed to be talking about what? about the upward force that is affecting our body. So the F up is going to be the weight of the object, which is mg, plus ma, which is mass times acceleration of what? Of the body. If we are talking about F down, the one that is going down, we said we are going to subtract the accelerating force. So it is going to be mg minus ma. That is the force is going up, or the force that is what? Going down, which is the same thing that I was trying to explain if we are given a condition of two masses suspended by a rope. Let's say we've got two masses that are being suspended by a rope in this case. Considering to say we can have, let's say this is where we have our object, and we've got two masses that we have. The first one, it's our A, and the first one, it's our B. So what is going to happen is that these masses that we have, they can be affected by a certain acceleration depending with the direction of the mass, the direction of where the object is going, which tells us that if this part is going up, when this object is going up, what does it mean compared to these two objects, A and B, in terms of their mass? What can make object A to go up, and what can make object B to go up? It means the object A is going to be having the smaller weight or the smaller mass for it to go up. Because remember the scale concept, the one that has got the bigger mass is the one that is going to drag down, and this one with the smaller mass is the one that is going to go up. So meaning to say, in terms of the masses, for this one to go down, to be facing down, it means we have a bigger or the larger value in terms of mass in this case. So the mass of B is going to be greater than the mass that is appearing at what? At A, for this object to go down, which is opposed. If B is going up and A is going down, it means A is having a bigger mass than what? Than B. So the one that has got a bigger mass is the one that we are going to see going down. The one with a smaller mass is the one that we are going to see going up. That is what we are simply saying. But the concept is not going to change, because once we're talking about going up and going down, it means we are going to have at the end the same thing about the force going up and the force going down. So it means for object A, the one that is going up in this case, we shall be talking about F up on that, or on this side of A, which is going to be the same mass times gravitational acceleration plus the accelerating force, which is ma. But I said now this part you are supposed to be careful, because you are talking about the mass that is affecting object A, the one that is going up. So this will be the mass of A, the mass of A. If we are talking about object B, the object B in this case is the one that is going down. So meaning to say we shall refer to the object B as F down. So meaning to say here we shall be talking about F down, which is equivalent to mg minus ma. So talking about these two masses at the end, for us to say this is going to balance, or this is just like a condition of an equilibrium, to say these two are balancing, it must follow that the sum of forces going up should be equal to the sum of forces going down, whereby we are simply referring this F up or F down is simply represents the tension or the tensile force in the rope. When they ask you about the tensile force in the rope, it can be found from these two, simply our tensile force in the rope. So when we are talking about the tensile force, it can be F up or F down, because at the same we are saying they must be equal for it to be balancing. So here we are representing the tensile force in the what? In the rope, or in the strings that we are given. So here we are considering a rope, or they can give it as a string. It's one and the same thing. So by knowing that F up is equal to F down, it means we are talking about this formula for F up, the one that we are saying mg plus what? Plus ma must be equal to F down, the one that we are saying mg minus ma. But considering to say, if this is from object A, this is the mass of object A, the mass of object A. If this is for object B, let's say our B is the one that is going down according to this sketch or the diagram that I'm having, meaning to say this is the mass of object B, the mass of object B. So at the end, this formula here can be used. With this formula, they can play around with this formula. They can ask you to calculate either the mass at B, they can ask you to calculate the acceleration that is occurring. So this acceleration is the same that we see here. The same as the gravitational acceleration here are the same. What is different are the masses, to say this is the mass of object A. This is the mass of what? Of object B. But this gravitational acceleration is one value, the A is the one value. So meaning to say they can ask you to find the value of A, you have to form an equation. They can ask you to find the value of B, mass of object B, you have to formulate an equation. So the idea, I think we are there. And I said the tensile force in the rope is given from, maybe you calculated everything is there. You can use F up or you can use F down to calculate your tensile force in the string or in the rope that you're given. Okay, so let us see what we have on our vertical movement with these formulas that we have. And also with the idea of that last part that we talked about in our previous class. We are given the first part of our question that the mass of a lift is 600 kgs. So there is a lift that we have. It has a mass of 600 kgs. All right, so what is happening with this lift? The maximum tensile force that the cable supporting the lift can withstand is 7 kilonewton. So they gave us the tensile force, meaning to say, what are we given when they are saying the tensile force? The tensile force is the one that I was saying, it can be F up or F down, depending with how you're given. The tensile force in the rope is your F up or your F down.
Yeah.
So this is, we are talking about a lift. So this one is the tensile force that the cable supporting the lift can withstand. So meaning to say, where is this tensile force? We can represent it as F up because it is supposed to be lifting the object. So the force that is, because we are talking about a lift, which has got a mass. So when going up, it means we are going to have a tension in terms of the force. And this is our tension that we are given, which is what? Which is 7 kilonewton. But this tension, I'm simply saying the tensile force is simply your F up or your F down. So we can simply say we are given F up as 7 kilonewton, or we are given F down as 7 kilonewton, because at the end I said F up and F down should be equal. So let us see what we have again. The question is to calculate the maximum upward acceleration. Take note what we need. The maximum upward acceleration are allowed upward. Meaning to say we are talking about what there? We are talking about using this formula as what? As F up. So meaning to say we are going to consider F up there. All right. So this is our A part. All right. So let us put it here. So we need to calculate the acceleration. But if this is going up, so meaning to say we are considering F up. And I say the formula for F up is given as what? Mg plus Ma.
G plus Ma. Yeah.
So if we have this formula and we have the mass, we've got the mass of the object, we've got our F up, which is the same as F down, and we can take that one, which is the tensile force that we're given. So meaning to say F up we have, which is 7 kilo. 7 kilo simply means it's what? 7,000, which is equal to mg. Do we have the mass? We've got the mass of 600. So it's 600 times the gravitational acceleration of 9,8, which is the one that we are given in our formula sheet. So you use the G that you are given, but mostly your G in the formula sheet is what? 9,8. All right, plus MA again. The mass, we are still talking about the same mass that we had. So our mass being what? being 600. So we are supposed to
Yes.
calculate what? We are supposed to calculate the acceleration there. So what is going to be our acceleration? So this one is a play around with our calculator. So we've got 7,000 is equal to 600 times 9,8 gives us what?
600.
All right, so that's something like 5,880 there. All right, let us just see on our calculator also so that we can verify if we are having the same thing. So this is supposed to be 5,880, which is 600 here times 9,8. So we've got 5,808. All right. So this plus what? Plus 600A. So now we can make A the subject, transpose this to the other side. It becomes a negative. So we've got 7,000 minus this one. We can just go subtract on our calculator, and 7,000 minus that answer that we got, it's gonna be 1,120. Which is equal to, we are remaining with what here, because we want to calculate acceleration. So there we are remaining with the 600A. So just divide by 600 both sides. We have got our acceleration there. So this answer divide by 600 is going to be 1,866, and that's all. So to 3 SF, it's gonna be what, to 2 decimal place or 3 decimal place, depending what you're given. If they say 3 decimal place, it's gonna be 867. So it's gonna be 1,867. So this is acceleration, and our acceleration is supposed to be what?
Meters per square inch.
Meters per square second. All right, so that is how we could have answered this first part. We were given that when it is going up, so when it is going up, we use F up on our calculations. If it is going down, we have to work with what? With F down. All right. Then the second part, now they're saying calculate the tensile force. Take note, we are still talking about the tensile force, and I said the tensile force can be what? F up or F down. That is our tensile force. So here now they're saying in the cable, when the acceleration is, they are now giving us when the acceleration downwards is, take note, where are we going? Down.
Downwards, yeah.
So meaning to say this tensile force that we are talking about this time, which is going down, is represented by what? By F down. We have to calculate F down this time. And what is the formula for F down? All right, we are given acceleration here of what? Of 0,4 meters per square second. So as our formula for F down, we said F down is equal to what? From our formulas, we said this time you subtract mg minus what? Ma. So that is what we have, of which our mass is still the same. Our mass here, it was 600 kgs. So we have the mass here, 600 kgs. So that means this one is simply a substitution, and we can just substitute our values here. So meaning to say our F down is going to be m times g, which is our gravitational acceleration. So it's 600 times 9,8 minus ma, mass 600, times, take note, acceleration. It's not that one that you calculated. It's this one they gave you on this question. They said if this, so you use the one that you are given there. So I don't know if we are together. All right, so we can combine this, but we multiplied this one before. If you still remember this one, 600 times 9,8, we got 5,808. So that was, all right, 5,800, 5,808, and minus, then we can multiply 600 by what? 600 by 0,4. So by 0, that will be 240. So you're going to subtract 240 in that case. All right, so 5,880 minus the answer that we got is going to be 5,640. So this is the force, meaning to say the tensile force measured in newtons. As long we're talking about force, go back to the what? To the newtons. All right, then there is this question here now. I want you to be very, very careful on this one, whereby they will ask you now to calculate the force in the cable when the lift is moving at constant velocity. What does it mean now when it is now moving at constant velocity? The major part there is constant velocity. So it means there is no acceleration that has been added or subtracted from there. We are just talking about the normal weight of the that is when it is moving at constant velocity. It means our tension in that case is simply going to be what? Our tension or the force that we are given is simply going to be the product of mass times what? Gravitational acceleration. We are not going to add anything to say plus MA or minus MA. This part that we're adding or subtracting before, it's no longer there. It's now at constant velocity. Nothing is added or subtracted. So simply meaning to say our answer is going to be what? Already we have got mg here. We calculated mg before. That was 600 times what? Times 9,8. Which gave us 5,880 Newton. So that is how we can have this type of, so be careful of that type of a person when it is now moving with constant velocity. It's different to say it's going up or going down. No, we are not having any acceleration, any accelerating force being subtracted or added. It's no longer there, this part. All right. I don't know if this typical question is clear.
Yeah, it's clear.
So
No?
This is how they might give you these questions as. All right. So I want us to check the other part here. This one is just the same as the first part that I was trying to explain of a certain mass that is suspended by two ropes like this. That is, we've got a rope that is suspending two masses. I mean, so here we've got the fig shows two masses suspended by a rope, which is mass A and B, that passes over a frictionless pulley. So meaning to say we are not considering the friction in this case because it's what? Frictionless. Mass A being 4 kgs, so we are given that this object A, it has got what? It has 4 kgs. And mass B being what? Being 3 kgs. We've got the mass of B. The masses are allowed to move freely. That is, the friction is not considered in this case. We are just working the object normal as it is. So they're now asking us to calculate the acceleration and the direction of the acceleration of the masses, meaning to say we want to know where is this acceleration going? Is it going because of what B is, what A is causing, or what B is causing? That is what we are talking about. So in this case, like I was saying, because what we know about this, take note, we need the acceleration. And we are not even given the tensile force. If we were given the tensile force, we're going to use the tensile force as a formula. But remember, we said whenever we have got this type of a question, whenever we're given these objects, we can consider the masses, the forces, to say the sum of the upward force should be equal to the sum of what? The downward forces. So you need to know now which one is going up, which one is going down, because they just give you a diagram like that. You do not even know which one is going up. So which part now tells you that this one is going up or this one is going down? That's where I was explaining the idea of what? The mass that you are given. The one that has got a smaller mass, it means it is the one that was raised up.
It's
gonna go up. The one that has got a bigger mass is the one that will go down. This one is going to go up. So meaning to say B, which is the one of 3 kgs, is going up. And the A here of 4 kgs is the one that is what? That is going down. So that is what we need. So this one now, when we are saying F up, what is our formula for F up? We know that this is going to give us what? Mg plus what?
Mg
plus Ma.
Mg plus Ma.
So it must be equal to Mg minus what? Minus Ma. But now considering to say, we said which one is going up, which one is going down here. We said B is the one that is going up.
Up.
So meaning to say here we consider the mass of object B, the mass of object B. The one that is going down is the A. A is the one that is going down. So here we have to consider the mass of object A and the mass of object A. This M is representing the mass from object A, the one that is going down. So now we can substitute our values. So let us try to substitute our values. What is the mass of object B?
Mass of object B is equal to 3 kg.
So you're going to have 3 times gravitational acceleration of 9,8 plus Ma. We are still at B, the mass of object B. So it's going to be 3A, because here we've got acceleration, the one that we do not know, is equal to Mg again, but this one is mass of object A. So the mass of object A is what? It's 40 times what? The gravitational acceleration of 9,8. Minus Ma again, the mass of object A is the one that we are considering, the mass of object A, which is 4, but times the acceleration, which is A. So what has happened here? We have formulated an equation. This one that we see here is simply an equation that we are supposed to solve, because our question is to solve to find A, which is our acceleration. So we can simply simplify these values, and depending with how you want to solve, you can maybe simplify this one stage by stage, which is fine. 3 times 9,8 first, which is 29,4. So 29,4 plus 3A is equal to, you do the same, you multiply 4 and what? 4 times 9,8, which will be 39,2. So we're gonna have 39,2 minus 4A. So from this part, we can collect our like terms. We can take 4A to this side so that it can be a positive. So that will be 3 plus 4, which is what? 7A. Then we can take 24,9 to this side so that it can be a negative. So meaning to say, we are going to subtract 39,2, this one, minus 29,4. So that will be what? 9,8. So we are going to end up here with 9,8. So to find A, simply divide by 7 by 7. There we have got our A representing acceleration. So this answer, if we divide it by 7, what are you going to have? Gonna have 1,4. So this is the value of A that we are having, which is 1,4. Acceleration, which is measured in what? Meters per square second. So the question is that it's in which direction now? Which part is possessing the 1, which part is taking control of the 1,4? The one that is dragging this down. Say the one that is dragging the other one down. So it's in the direction of what? Of the 4 kg, because the 4 kg is the one that is dragging our 3 kg down at the end. Or we can consider the direction that we are having in this case to say which direction are we having our object at, meaning to say at the end we can just give this a conclusion to say it's going to the side of what, in the direction of what, of the 4 kg. So we can just say the one in the direction of what? Of 4 kg, in the direction of 4 kg mass. All right. So that is how we can have this one. Let's see the other part now. They are asking on the B part. On the B part, what are we given now? The tensile force in the rope. If you are to consider what I said about this tensile force, to say this one, it can be taken either from two ways here. The tensile force. This is our tensile force, that it can be taken from what?
From
force
F going upwards
or F down.
And force down.
So this one is in your hands now, because you have calculated the acceleration. In this case, you have the acceleration. Now they just want the tensile force in the rope. So it's gonna depend with which formula are you going to apply. So if you want this tensile force to be equal to F up, meaning to say you shall use the formula for F up, which is mg plus ma, which is going to be the same if you are to use F down. We shall have this as mg minus ma. You are supposed to obtain the same answer. So I want you to verify so that you see if we've got the same answers. As for now, I'm just going to use the first one for F up. So meaning to say, if I am using F up, my formula is going to be mg plus what? Plus ma.
Plus ma.
So this one is just a repetition of this part, because already we calculated here our acceleration. So it's just now substituting our acceleration. Already the first part, we have it mg, that is mass. Our mass, remember, it was what? 600. Is that sorry? Sorry. So the mass there, we remember I've got two objects there. I want the mass for F up. For F up, this was the side of F up, and this one.
Up.
So the mass there was what? 3. Remember our mass there for F up, it was 3. So it's going to be 3 times 9.8. It's just a repetition, only that you are now substituting that A. Here, our mass still at 3 times the A now, the acceleration. We calculated our acceleration. It is what? 1.4. So meaning to say, if you are using F down, you are supposed to work with this side of what? F down. We are supposed to use the mass of object what? The mass of object A. But having the same, we must obtain the same answer there. All right, so that is going to be our tension in this case. So this one, we can just simplify this at once on our calculator. Let's see. But this one, you can just simplify everything at once, or you can do it, stage by stage, and or you can do it just one and the same thing. So it's 3 by 9.8 plus what? 3 by 1.4.
3 by 1.4.
So that is gonna be 33.6. All right. So the same answer that I'm saying here, if you were to use this one, you're supposed to obtain the same answer again, 33.6. You're supposed to have the same answer. So this is how you calculate your tensile force. We are supposed to be very, very careful on our tensile force. It's simply from our F up or our F down. It's like the equivalent force that we are having. All right. So like I said, it's just as you can see, it's just a matter of playing around also with the formulas. So this one, I think you can try it because it's just the same as that one. Calculate acceleration. The tensile force in the string is just like the same as that one. So I want you to try and see. But here, just a clarity part, we are given that two masses of 4 kg each are attached to a light string. So meaning to say we've got two masses that we have, they have 4 kgs each. But now the string passes over a pulley. an extra mass of 1 kg is placed on one of the masses, on one of them, we placed an extra 1 kg so that they can be what? A downward acceleration now. So meaning to say, if we are to add 1 kg on one side, only one of the masses, meaning to say we are going to remain with the 4 kg, then the other one is going to be what?
5 kg.
Because we added 1 kg there. So maybe this is what you want to call A, this is what you want to call B. The idea is going to be the same. So if we are using this, which one is going up, which one is going down?
Yeah, this one A is going up, then B is going down.
Exactly. So A is the one that is going up and B is the one that is going down. So meaning to say F up is equal to F down. You use the formula, you calculate A just like the previous part. After calculating your acceleration, you use that acceleration to calculate now the tensor of force, which is the one that I'm saying is the same. So I want you to cross-check, but if you are to have this properly, it must give you something like 1,089, but I want you to try it out. And this one, your tensor of force must be something like 43,556. So just try to use the same idea that we had from the previous one. I think these ones, they are just the same. Let's consider this one. It's different from what we had from these other two questions that we had. They're asking us to refer to this diagram that we have, the fig that we have there, and calculate the force F necessary to accelerate the 9 kg mass upwards. Take note, the 9 kg is supposed to go what?
Upwards.
This one is supposed to go up. So meaning to say on the 9 kg, the force that is supposed to affect here, it's F up, because they are saying it upward. So you're supposed to talk about F up. At a constant acceleration of, there is a constant acceleration there. So on this part, this acceleration is going to affect two things. All right, let's just hope we are going to win. All right, I don't know what's happening with this board here today. So as I was explaining here to say what is going to affect our object because of this part that we are given, that the 9 kg mass is going what? Is going up. So it means here we are considering F up. This is the mass that we have to consider there. All right. But while it is going up, it is also affected by an acceleration of 0.5. And we know that this F up has got acceleration because our formula is given as mg plus what? Plus ma. So that's, we need what? We need the acceleration there. But as it is going up, take note here, there's a force F here on this object, meaning to say this object also is, because this object is being taken up. But with the influence of the 20 kg, the 20 kg is also influencing. So meaning to say on the 20 kg, we are going to have an accelerating force that is affecting our 20 kg. And our accelerating force is represented by what? By ma. Because this one is also due to the acceleration that is there. It's gonna influence a force. This one, it influenced its own force, we called F up. But as it is having this force, it is also affected by the frictional force of what? Of 40 Newton. We also have the frictional force of 40 Newtons in this case. And our question is to calculate the F, the F. If you are to consider from that last part that we talked about, we said how do the total force is taken as what? The total force. Yeah, from the when you're talking about just on a horizontal ground, how do you calculate your F, your total force?
Yeah, we can just say total force is equal to F, it's equal to F friction. It's initial, F initial plus, it's equal to MA.
in order for us to have F is gonna be F
initial is equals to it's F opposing is equals F is equals it's F.
So we are supposed to consider all the forces, isn't it? In order for us to have this. So in that part, we're talking about the frictional force and what? And MA. But now we no longer have this part alone. There is F up also, which is part of the forces, meaning to say we are going to have F up together. The frictional force is gonna be considered, and also the accelerating force of this object that you are given here of the 20 kg. It also have to be affected.
Yeah.
So these are the forces that we are going to take into consideration in order for us to have the equivalent, the equivalent force. So here we simply gonna need F up, of which the formula for F up we said F up is going to be mg plus ma, and we are told that the acceleration here is what? 0.5 meters per square second. So it's got 0.5 meters per square second affecting this object and also affecting this object, 0.5 meters per square second. So our F up, we said it's mg plus ma, our mass of this object, this is the one that is we are talking about, the one that is going up. So it's gonna be 9 times 9.8 plus ma, which is mass of 9 times acceleration of what? 0.5. So in this manner, we are supposed to obtain our F up. All right, so let us check on our calculator what is going to be our F up. 9 times 9.8 plus 9 times what? 0.5. So this is going to be what? 92.7.
92.7, yeah.
Newton. All right. So this is our F up, the one that is going up due to the accelerating force at what? At this object of 9 kg. And we said we also need what? We have got F up. The frictional force is there. This one we are not calculating, we are already given. So we also need what? MA. So our MA is from this object that is on the horizontal ground. You see, MA is from the horizontal ground. This one is on the horizontal, but this one it's a vertical. So do you see this one is a combination of a vertical movement and a horizontal movement?
Yeah.
So we need to know the force that is affecting our object, which is the accelerating force, which is MA. So it's gonna be 20 times 0.5, which is 10 and 10 Newton there.
That's 10, yeah.
All right. So now with these forces, we are going to combine them now to obtain our F, because we are saying our F is going to be the sum of all the forces that we are given, which is F. Our F up 92.7 plus the frictional 40 Newton there, MA, which is our MA is what? Is 10. So this we are going to add so that we have the equivalent there. So if we are to add this part, what are we going to have at the end? So this is going to be 92.7 plus 40 plus 10 is what? Is 50. So
it's 142.
142.7. So we are going to have 142.7 Newton. So this is the equivalent force that is affecting everything that we are given from this information that we have. I don't know if we are together. Exactly. So this is how you're gonna have your questions. So this one was it's a combination. If you take, we are considering everything at once. The horizontal movement, the vertical movement also at once. Yeah. So we have to consider all the forces now. They are supposed to be part of what? Of our external, which is the total force, which is represented as what? As F. All right. So we'll see on the next part so that we can try to work on the other part. But like I said, let's try by all means that tomorrow we continue from that our maths, so that we can see what we can actually do from there. So I will just try, if I find time, so that I will just compile again questions so that you can just try to work questions now from past exam papers on whatever that we have done. We have to use question papers as a revision. All right, no problem. We'll see you tomorrow then.
Okay, I really appreciate it.
Oh, okay, sure.